Hey everyone, welcome to this explainer. Today we are diving into a massive, and I mean massive, paradigm shift in UI architecture and software design. You know that feeling when you're just totally frustrated by a clunky interface? Or when you get completely lost in endless nested menus? Well, we're going to fundamentally challenge how all that information is organized. Let's just jump right in. So, here's the hook. What can a tiny 1980s robot possibly teach modern AI? I know, it kind of sounds like the setup to a geeky joke, right? But the answer actually holds the key to one of the most brilliant UX models we have for the artificial intelligence era. We're going to unpack this incredibly unexpected connection between retro-embedded robotics and the cutting-edge software you and I use every single day. All right, Section 1, the Micromouse competition and solving the maze. To really get this, we got to travel back to the late 1970s and 80s to a legendary robotics competition called Micromouse. This was literally the ultimate proving ground for advanced embedded systems engineering back in the day. Now, the premise was deceptively simple. The challenge? Drop a tiny autonomous robot, the mouse, into a maze filled with unknown walls, dead ends, the whole shebang. And it had to execute 4 specific steps. First, explore the unknown maze. Second, build an internal map. Third, learn the optimal routes. And fourth, rerun that maze at absolute maximum speed. See, that first pass, that was purely for discovery. But every single pass after that was all about pure, unadulterated optimization. And here is the big aha moment that honestly most people completely missed. Micromouse was never really about mice solving a physical maze. Nope, it was actually about state space optimization under uncertainty. The real value here was teaching a system how to move as efficiently as humanly possible through an information topology. It was all about pathfinding, graph theory, real-time adaptation, and memory. Which brings us to Section 2, AI's hierarchical tree problem, and the trap of nested folders. See, modern AI systems internally behave a lot more like a micromouse than we realize. They desperately want to reduce traversal costs. But when humans build software, we tend to force both ourselves and the AI into these deep, restrictive, hallway-style architectures. So why does AI default to these forests of deep nesting and hierarchy? Well, it's because language itself is fundamentally hierarchical. And since AI interprets so much through the lens of language, it naturally defaults to building giant, branching menu systems. It literally leads us straight into what I like to call tree depth hell, where objects just get buried, completely disconnected, and stuck in these rigid little branches. Think about traditional directory trees for a second. Folders within subfolders within subfolders. They are absolutely terrible for operational movement. They cause deep nesting, dead ends, orphaned files. But when a micromouse optimizes a maze, it figures out that the fastest systems actually eliminate dead ends entirely. It naturally produces interconnected routing and loops. It produces a roundabout. And roundabouts give you multiple entry points, super fluid navigation, and really resilient rerouting. And that leads us to a real game changer. Section 3, enter the roundabout system, a new UI/UX ontology. If we actually want high-efficiency software, we have got to ditch that hallway logic where you're forced down a single path. Instead, we need a central truth without forced intersections. So in a roundabout graph system, your database acts as the center roundabout. You can enter from a property, a marketing campaign, a text message, whatever, and every single path reconnects to the exact same underlying truth. This completely changes the game for software efficiency. In computer science terms, this ontology gives you a vastly superior big O complexity for operational traversal. Your traversal cost scales beautifully simply because you aren't forced to painstakingly climb all the way back up a massive nested tree just to get to a related node. I really want you to burn this definitive statement into your mind. Trees are optimized for storage, not traversal speed. Traditional software is always asking, where should this file go? But Micromouse thinking asks, how quickly can reality flow through this system? Storage is static. Traversal, on the other hand, is dynamic. It's operational. And that is exactly why UI and UX benefit immensely from a micromousing ontology. When you start micromousing for your UI, you stop agonizing over categorization and start looking for the absolute shortest operational path. You want to minimize clicks, context switches, dead ends, but most importantly, you want to minimize re-navigation. You should never ever have to painfully backtrack the exact way you came just to access related info. Being able to move laterally without hitting the back button 6 times, that is the hallmark of a vastly superior interface. Okay, let's look at the practical side of this in Section 4, eradicating UX dead ends and surviving the maze. Before we even start obsessing over visual polish or trendy front-end animations, we have to use this Micromouse methodology to validate that our architecture is actually deterministically traversable. Because if your software topology is a roundabout, there are certain catastrophic UX failures that are strictly forbidden. You literally cannot have a dead end where a user gets stuck. You can't have context collapse, where the user suddenly forgets which client or property they're even looking at. There's no room for relationship blindness, navigation amnesia, and absolutely no duplicate truths, where two screens show contradictory information. Workflow continuity has to survive at all costs. So, to prevent those forbidden states, we follow the core navigation rule. Every single major entity screen in your system must instantly answer 4 critical questions. What is this? What is related to it? What can I do next? And how do I get back? If a screen can't answer those, well, you don't have an operational system, you just have an isolated, dead-end web page. Which brings us to a really firm reality. The CRM must never feel like disconnected screens. Honestly, it doesn't matter how beautiful your user interface is. If the underlying ontology isn't naturally traversable, your software is just broken. Connectivity has to replace burial. Relationships have to replace containment. Now, I want to challenge you. Seriously, think about this. If a robot had to complete your daily workflows, what paths would it discover? Do a little mental Micromouse crawl on your own software right now. Would it expose unnecessary menus, hidden bottlenecks, orphan systems? Because guess what? AI is already capable of running these internal competitions against your software topology, and it will immediately expose all of that operational waste. So we're going to end this explainer today on a pretty provocative thought. The future of software is not trees. The future of software is optimized traversable graphs, and AI may become the ultimate Micromouse. By shifting away from deep, hierarchical folders to interconnected roundabouts, we aren't just organizing data anymore, we're unleashing it. We're letting reality flow through our systems with zero friction. So what does this mean for the systems you use every day? I hope this completely changes how you look at them. Thanks for joining me for this explainer, and hey, keep optimizing those mazes.